Hello everyone, I'm Otso. I'm the founder of the token company and we do LLM input compression and optimization. So here I did not prepare a slide deck, but I do have our own dashboard from our company website. And here's an example of what we do. We basically use machine learning models to analyze context, analyze token level importance, and get rid of tokens that do not bring any meaningful information to the context and wouldn't affect the future output of an LLM. So here's just a random text I generated with like ChatGPT, asking it to like write a text about artificial intelligence. And I can like go to a new one. Yeah, here's the exact same text. We can compress it using different aggressiveness levels. Here's where we're compressing it by 38%. Let's run a comparison comparing, I'm gonna ask it to actually do this, and let's ask it, what are the 3 main points of this text, concisely? Let's see. AGI has arrived, AI has reached AGI status, redefining intelligence, societal impact, societal responsibility. Basically the exact same stuff, but reworded because of LLMs being, or LLMs being random. And here we see a lot, like this is a 38% input token reduction. The cost reduction is like minimal. This is like just rounding error. Yeah, and what does this mean in a real world production environment? Here is one of our customers, a company called Pax Historia, which is an LLM video game company who basically gives video games using LLM as a game engine. And here's user quality rating examples. So these are rated by giving users 2 LLM generated outputs and asking the user to compare which of these outputs is better. Here we have Claude Sonnet 4.5 compared to Claude Sonnet 4.5 with our compression model included. And now, as you might be wondering, or as we were wondering before, like why is there such a big increase in quality? Even though we're reducing context, we're compressing it. And usually when you talk about compressing, you're talking about, reduction of fidelity, which usually means quality loss. But the main theory for why we have a quality increase was also presented by the Chroma speaker, is because when you have context rot, meaning you have too many tokens in your context window, you get worse responses from LLMs. And we help with that by reducing the amount of context. So here is a fine-tuned model with Claude Sonnet. Here is a fine-tuned model with Gemini 3 Flash Preview compared to the normal 3 Flash Preview. And this is a live ranking around 54,000 votes per comparison. And yeah, we're looking to hire more LLM researchers. I'm sure there's going to be some questions. Yeah, that's it. Thank you.
All right. Raise your hand up if you have questions to Otso. There's one right there.
Thank you for the presentation. Simple but extremely impressive. Question: How does a customer implement this, like from a customer point of view?
Yeah, so we basically have documentation. This is the whole implementation. It's a one request that you make to our compression API before you send your request to OpenAI or Anthropic or any other LLM call.
Okay, gotcha. Thank you.
Thank you for your compressed presentation, I guess. But my question is, how does your compression model basically decides what token is like a bad context in that particular context? Because there's generally not a very standard way to, I guess, have this. Like we can have NLP stop tokens, but how is that decision based?
Yeah, so we are not using any traditional NLP methods such as removing like all the stop words or all the words there or a or and, because in some cases those would be relevant. So what we do is we train our own machine learning models, which are trained on context analysis and compression. So they're trained on millions of examples of original context and the optimal version of that context. And we run these models at around 2.5 million tokens per second processing speeds. So they're not generative LLMs, but they're not also NLP algorithms. But they're machine learning classifier models is what we use most of our compression.
Okay. Yeah, thank you.
Yep, we have time for more questions. There's one here and one back there.
Hey, so I was wondering what types of configurability do users have? Like if I'm an enterprise, I noticed the, like, I don't know what you call it, the slider bar you had where it was like how aggressive it is or something?
Yeah.
How aggressively it compresses? Okay, besides that, are there other ways an enterprise or a user can tune it based on certain knowledge that might be specific to that organization?
Yeah, so one major thing we do with all our bigger clients is we fine-tune specific compression models for their domain and task. And that's why we're able to reach very high levels of compression with very low latency and very high accuracy increases. So the major way we implement this per enterprise is enterprises tell us what type of data they're using or send us data examples. We fine-tune a specific model for them. For example, in Pax Historia's case, it was Pax Bear 1.1, and then we run that with the enterprise. That's the main configuration we have with companies. There's also like aggressiveness. You can have, that fine-tuning and aggressiveness is the two major things we do.
Okay, thanks.
Yep, there was a question back here.
Here, back here. Yes. So this is such a useful and practical idea. And I just want to give you a suggestion that instead of focusing on saving tokens, maybe you can focus on generating better responses by do the compressing, because after you do the initial compression, depending on the user prompts, the way you compressed it can generate different responses. So maybe before doing the compression, see what is the user prompt, and then based on that user prompt, do the compression and then feed that to LLM to get a better response.
Yeah, so that is one thing we're also doing. We don't do it in production. What the question he asks is, can we do compression with like a user asking, like, keep all the information regarding, or like if the user asks, what are the 3 points in this text, then you would do the compression so that you would store the information about those 3 points. But the main reason we don't do that is because we want to be supported in multi-turn conversations. So this means if your question at first would only require one paragraph in a huge context, but then you ask a new, and like you would delete everything else except that one paragraph to answer that one question. But then if, again, like the user does a new turn and asks another question from the context, then that would have been compressed away since you're doing question-aware compression. So that's why we're doing completely question agnostic compression, so we can continue multi-turn conversations and be used with agents.
And we have our last question here.
How do you assess the accuracy, and how do you actually figure out that what's the aggressiveness level appropriate for different situations?
Yeah, very good questions. The accuracy we measure in two different ways. We run normal LLM benchmarks without compression and compare their accuracy results to the same benchmarks with compression. And we see the delta there. And another way we measure accuracy is by giving users two LLM-generated outputs and asking them to compare which is better. And the aggressiveness question is an unsolved problem for us. Currently, we just try out a couple different settings for each user, see which is the optimal one, and have them continue using that, or we let the user test this themselves.
Excellent. Thank you so much, Otso.
Thank you.